Alright, hello and welcome to the metals and the extraction video. On the exam paper, I'd recommend having the exam paper with you while you do this video. Yeah, let's get going. So the first question, question 6, you start by drawing the line of best fit through the top of as many bars as possible. You see this one it goes through 3 of them, which is probably what you want to do. And we can also see how the second line, this one, if it goes through the potassium bar, it cannot go through the other bars, whereas if there was one that goes through the sodium bar, it would be much closer to the line of best fit. So that's the first one. Part B asks for similarities when potassium and lithium are put in water. You get 1 mark for the observation and then another for the reason. The exam will not accept the similarity that they both melt or they both form a ball shape because lithium won't melt in water. Also, it won't accept that potassium reacts more violently. Just take a moment, pause the video to understand each of the points that are listed. The next part asks for a balanced symbol equation. So you'd start with what you know. The reaction is between lithium and oxygen, and you need to know the molecular formula for the product, which will be lithium oxide, Li2O, as lithium forms a 1+ charge and oxygen forms a 2- charge. Then, to balance the equation, we'll keep the number of oxygens the same, and we'll need 2 lithium oxides and 4 lithiums to balance it completely. The next part then asks for why potassium and chlorine will react the most violently. This list gives the reasons, pause the video and take a moment to understand all of them, but they're mostly due to how tightly potassium and chlorine hold on to their outer electrons. So the next question is another balancing of the equation. So they were told that HCl reacts with NaOH. So we can start by doing that. And then we're also told that only sodium chloride and water are formed. So we can write those in. And then finally, to balance it, make sure that all the atoms are the same on each side. And they are balanced here, so there's no need to do any balancing at all. The next part, X is a pipette, or a 25mm pipette. And the final bit, the indicator, is used to identify when the endpoint is reached. The exam also accepts the other answers given. Let's just take a moment to work those out. So, first part of the next question is to calculate the mean. So we add all the congruent values together. In this case, that's all the values, and then divide by the number of values that we used, as so. Then for part 4, we see the temperature rise. As the neutralization reaction is an exothermic reaction, the heat will continue to rise until the solution is neutral, then it will begin to fall back to room temperature as no reaction is happening and you're just adding room temperature liquid. Then for part 5, the HCl neutralizing the alkali is half the concentration of the original solution. This means that there are half the number of moles of acid in each milliliter, so we need double the volume, double the milliliters, in order to neutralize the alkali. So this will be double 18, which is about 36. Next question. You say this is a very exothermic reaction, which means the reaction gives out a lot of heat. This heat is enough to melt the iron produced in the reaction, so it will be released as a liquid. You can also get a point if you mention the melting point of iron is 2500 degrees C. For part 2, you need to know the formula for aluminium oxide, which is similar to that of the iron oxide as they both form a 3+ charge. We then need to balance the equation. So we can see that the only atom balanced is the iron, so we need to not balanced is the iron, so we need to double the iron, and that fits in the equation there. The reaction, we can see that aluminium changes from aluminium oxide, changes to form aluminium oxide. This is a gain of oxygen, which means the aluminium is being oxidized. Be careful to ensure that you say aluminium is oxidized and not aluminium oxide is oxidized. You can also answer the question in terms of loss and gains of electrons. So aluminium is oxidized as it loses electrons. Finally, we move on to this question. The reaction are all displacement reactions, so the investigation will show which of the metals in the reaction is more reactive. So by the reactivity series, copper is the least reactive, so that won't react with anything. Also, in the diagonally across the middle, the metal will not displace itself, so none of the reactions diagonally across the middle will react. Therefore, D is the only possibility. And on to the next question. The reaction will form copper sulfate, which is a blue solution, and then also silver will be formed on the surface of the copper metal. Silver is a shiny grey solid. You also need to remember that nitrate is an NO3 minus ion, so it will bond twice to a copper 2 plus ion, so 2 nitrates are needed, and this produces 2 moles of silver in the balancing of the equation. Question 4. So calcium has 2 electrons in its outer shell and will want to lose them. Oxygen requires 2 outer electrons to gain a full electron shell. So calcium will give its electrons to oxygen and form an ionic bond. Remember to include the charges of each of the atoms, well, ions. And both solids form a strong electrostatic forces between the ions. Be sure to mention that they are ionic bonds or bonds between ions. Also, the calcium oxide has a higher melting point as it involves 2 plus and 2 minus ions, so attraction will be greater than that with 1 plus and 1 minus ions. Question 8. This is quite rough. The scales on the graph, I did them, they're a little rough. You could probably do them better on either Excel or do it by hand. But basically the scales for the maths shouldn't go above 0.7 and the current shouldn't go above 2. The points should also be crossing at the appropriate points, and the line of best fit has to go through 0.00 as you are given this value, meaning that if there's no current then there will be no mass of copper deposited. For the value at 3.5 amps, find out the equation of the line using y equals ms plus c in calculating m. I did it roughly and found it as 0.3, but you might be able to find a better value using either a hand plotted graph or Excel. So using this equation, we can then do y is equal to 0.3 times 3.5, which comes out as 1.05. Accepted values for m are between 0.3 and 0.5, depending on how you did it by hand. The next part, the solution will stay blue as the concentration of the copper ions will stay the same, as copper will gain at one electrode but lose at the other. Question 2. Compound A must contain magnesium, but it cannot be magnesium metal as the metal will not react with the dilute acid, so it must be either magnesium oxide or magnesium hydroxide. Solution B is where copper has displaced hydrogen in the reaction to produce compound B, copper chloride, and the carbonate is released as carbon dioxide. The equation shown is zinc reacting with hydrochloric acid to form hydrogen and zinc chloride salt. Zinc forms a 2+ charge, and chlorine only forms a 1- charge, so you need 2 chlorine or 2 chloride ions are needed to form the salt. So HCl, there must be 2 HCls. For part C, the difference will be the formation of gas bubbles, formation of gas bubbles will be faster, or the fact that magnesium will disappear faster as magnesium is more reactive. Question 4. Sodium will be formed at the cathode, will not be formed at the cathode, as it's far more reactive than hydrogen. And for the balanced equation, you need to remember that chlorine is diatomic, meaning that it forms Cl2, so you need 2 Cl- ions, and they each lose 1 electron to give the equation shown. The final part, the indicator, will go purple as the sodium will form sodium hydroxide, which is a strong alkali. Part B, copper ions will gain electrons at the cathode. So in order to keep the solution blue, copper electrodes should be used, as the anode will release copper back into the solution at the same rate the cathode will remove copper. And then part 3, the outer shells of the oxygen. As shown, oxygen wants to gain 2 electrons, so it will share these 2 electrons to form a covalent bond, as in the diagram shown. Question 6. So reaction 2 is the reaction of carbon dioxide with carbon to form 2 lots of carbon monoxide. And then on to the formation of slag. This is through a reaction of, you do this through calcium carbonate, which then goes on to form calcium oxide and carbon dioxide. The calcium oxide will then react with silicon dioxide to form slag. You also get a mark for pointing out that this is a thermal decomposition reaction. Part C is about the properties of steel and steel production. For part 1, costs are reduced by using carbon scraps. Part 2, when the reaction is increased from 0 to 0.45%, the ductility will decrease, whereas the tensile strength will increase. This is because the carbon will affect the structure of the metal, which will increase the strength, but decrease the ability to put it into wires. These 2 properties are essentially opposites of one another. Part 3 wants to identify the percentage of carbon that should be in the alloy for it to have high tensile strength but low ductility. For these, you want to have enough carbon to increase the strength, but not too much that it decreases. For this, high carbon steel is desired, which is closest to about 1%. And for the final part, the alloy with the best ductility will be low carbon steel. Thanks very much for watching. Yeah, thank you.